Welcome to our presentation about AI, Artificial Intelligence. We'll take a look at the list of topics on this first slide and the way these issues intersect in the domain of artificial intelligence. A very brief definition from Janet, our AI Gal Friday, and guide will begin.
Hi there, I'm Janet, an anthropomorphized vessel of knowledge here to make your life easier.
Janet is the anthropomorphized, artificially intelligent, and encyclopedically knowledgeable being designed to serve, from the TV show The Good Place. What does anthropomorphized imply? It means a likeness to human beings. Intelligence is an attribute of human beings. For a long time, it was assumed to be the attribute that set humans apart from other beings. This assumption goes back thousands of years and is tied up with the development of religion, which placed humans at the top of the hierarchy of all living things. When we think about anthropomorphized intelligence, we think about the ways in which humans are intelligent. Humans articulate using language. What other attributes are relevant to artificial intelligence is akin to asking, what makes human beings human? Before we look at that, let's take a look at a few more academically oriented and useful definitions.
As Deloitte, we have the drive to explore new things. So that's one of the key reasons that we are organizing these kind of events, team up with different cultures, different capabilities, different technologies, etc., to basically explore new things.
Artificial intelligence is the brain that makes it all possible. And that's kind of the cool thing, because we can develop sensors that do amazing things, but if there's not the intelligence to interpret what that is, then we're not extracting the value from it.
AI is about also reasoning in the essence, and true AI in the sense that the systems are able to reason. Context-driven decision making or decision support is something, to be honest with you, I haven't seen that much around. And the very important part to me, if we look at AI, is also the capability to learn. Based on predictions, based on pattern recognitions, or whatever you want to call it, but the system needs to learn from its mistakes.
We went with our team to meet other people in AI. We met a few guys that were really interesting. They probably have some answers for us, and we probably will also be able to help them as well. So it was really beneficial.
And I really believe that it's important to connect the different initiatives and the people in this whole ecosystem of technology, trending technologies especially, such as AI, because I think that together, focusing on your own thing, you can do things quicker and better.
You've probably heard about the two technologies that will soon transform everything. Artificial intelligence has its foundations in machines that learn from experience. For example, an algorithm that gets better at chess every time it plays. And secondly, quantum computing is a new type of computer that replaces bits with qubits. This allows the 1 and 0 choices to be considered at the same time, producing vastly faster solutions to some types of problems. But what happens when we combine these technologies? Contrary to some headlines, it's not simply machine learning but faster. It's a fundamentally different approach to problem solving. Quantum machine learning replaces probabilities with amplitudes. You can think of amplitudes as arrows. They include a direction as well as a magnitude. This is crucial because depending upon their direction, amplitudes can cancel each other out, or they can be added together, allowing for much more sophisticated decision making. There are many applications for this new way of thinking. For example, in finance, some complex derivatives are path dependent, and evaluating a large number of paths can be computationally expensive. This makes them ideal for innovative new methods of rapid evaluation. In medicine and health, quantum machine learning can enable the designing of custom pharmaceuticals to treat conditions whilst minimizing side effects. Other applications could include optimizing radiation therapy procedures or streamlining the patient evaluation process. Autonomous cars, for example, require thousands of decisions per second in order to ensure that driving is both safe and efficient. This makes the process ideal for quantum AI. At Cambridge Quantum Computing, we're developing ways to take advantage of quantum computers. Our scientists have already made advances in pattern recognition, anomaly detection, and other areas of machine learning. This is complemented by our expertise in quantum compilers, encryption devices, and quantum chemistry. For more information about how quantum computing and quantum machine learning can transform your industry, please contact us at info@cambridgequantum.com.
You know, increasingly we're using automated technology in ways that kind of support humans in what they're doing rather than just having algorithms work on their own because they're not smart enough to do that yet or deal with unexpected situations. So we're interacting more and more with these systems. And so you need an interface that it makes sense for a human to interact with. And so a lot of these systems have an interface that is personified and that will talk to you. The effect that I'm so interested in, the psychological effect of us treating these systems like social actors is actually, we achieved that in the 60s. Like in the 60s, we had this chatbot called Eliza that Joseph Weizenbaum made. It's a really famous example of a really simple chatbot. All it did was answer everything with a question, like a psychoanalyst would. So if you were like, oh, I don't like my mom, it would be like, why don't you like your mom? And people would just open up and tell it all sorts of things, even though it was very primitive in how it behaved. So it's useful that we will engage with these systems on a social level because it's engaging for people and you can get people to actually use the systems more. But I do wonder whether there's any effect on our behavior, on our long-term behavioral development. It really gets interesting when we start talking about kids. You have these systems like Siri and Alexa that kids are interacting with, and if these systems are simulating lifelike behavior or a real conversation, then that could actually influence kids' behavioral development and the way that they start to converse with other people. There are some examples of this just anecdotally that we have so far. Like there was an article in the New York Times a few years ago about this kid, this autistic boy who had developed a relationship with Siri. And the mom was like, this is the best thing ever. Like this Siri is infinitely patient, will answer all of his questions, Also, the voice recognition is so shitty that he's had to learn to articulate his words really well, and it's made him a better communicator with other people because of Siri. But then on the other hand, you have stories like this one guy wrote an article a few months ago about how Alexa was turning his kids into assholes because she doesn't require any please or thank you or any of the standard politeness that you want your kids to learn in conversing with others. So, you know, I think it is an interesting question. The more we're able to simulate like a real conversation with these systems, the more that might get muddled in our subconscious in some way. One of the things that I think is really necessary is that we need to study more what impact this can have on our behavior. So we definitely need to be studying these interactions and studying the effects of these interactions. It's you know, a similar question to violent video games or pornography, or these are questions that have come up again and again, but I think that these systems bring them to a new, more visceral level in our psychology. So we need more research, and then depending on what the answer to that specific question is, we might need to think about design and use and maybe even policy for regulating these agents. Part of the problem is also that like this is such an interdisciplinary problem, or all of the questions that are coming up are so interdisciplinary. You need technologists, you need policymakers, you need users, you need researchers who understand psychology, who understand technology, who understand sociology. Like all of this is coming together, and you need people talking to each other. I would really like us to, in the next few years, to lean into the positive effects of the technology and develop structures the way that we have in other fields like medicine to ensure that we're using the technology in a responsible, ethical way.
Cognition is an invisible process that scientists study from many perspectives. Its process is used as a model for artificial intelligence, and it appears to shed light on the way thinking happens.
Hey everyone, Nick here, and it's no doubt that self-driving cars are going to change the way we live our lives. That is a total given, and I can very easily cover the incredible specifics, but truthfully, I want to do something different. I want to discuss the burden of such technology and what it means for engineers. Imagine you're in a self-driving car and you're about to crash into a group of 5 or 6 pedestrians. The only other option is to veer left and drive off of a cliff, meaning instant death for you, the passenger. What is the machine programmed to do? Let's check it out. Okay, so I'm all sure you've heard the philosophical equivalent of this issue at some point in your life, but it needs to be addressed. Should you kill one to save 5? And depending on the type of person you ask, you might immediately have your answer. But how does a computer, how does a machine interpret the value of a human life? Things like emotions, desire, value, principles are not binary, so how can you stuff it into a 1 or a 0? And that being said, where do we draw the line for the sake of our own morality? And the truth is, the actual painful truth, is that eventually a computer will need to be able to differentiate humans from each other. And that's going to be based off of pretty arbitrary measures. So now you may be telling yourself that, oh, these cars are so advanced, they'll never make mistakes. And as beautiful as computers are, they are also very rigid machines, and mistakes are bound to happen. And when a bunch of non-philosophers were asked the same question, 75% of them said that the car should swerve off the cliff and kill the passenger instead of the group of pedestrians. But something interesting to ponder would be if there were 2 children in the back seat. How suddenly does all of this moral calculus change? Obviously, none of us have any of the answers. All that we can say is that we truly pity the engineers, designers, and even lawyers that have to deal with the issue. And we can't just say, oh, hard code the machine to always save the pedestrian on the road. Because what if a pedestrian recklessly jumps in front of a car and the car and its driver are not at fault? What do you do? Most of all, it's tough, it's painful, but it's also very interesting, and I hope it gave you another insight into the burden that many people face when developing new technologies. And as always, thanks for watching, and I'll check you guys next time.
Here is a brief history of artificial intelligence in fiction, art, and fact. Myths about artificial intelligence go back to ancient times. In the classic story of Pygmalion and Galatea, the goddess Aphrodite animates the sculpture that Pygmalion has fashioned, fallen in love with, and desires for his wife. As a result of his work and the kindness and compassion of the goddess Aphrodite, this changes Pygmalion the sculptor and his view of women from one of disdain to appreciation and worship. During the Middle Ages, when Middle East culture and learning was flourishing, the polymath Al-Jazari created a musical automaton, which was a boat with 4 automatic musicians that floated on a lake to entertain guests at royal drinking parties. There are different interpretations about the way Mary Shelley's book Frankenstein ends. The monster vows to kill himself after the scientist who invented him, Frankenstein, dies. Does this mean that artificial intelligence cannot and is personified in this work of fiction as not wanting to live without the companionship of its inventor? Or has the tricky creature only made this vow to deceive other characters in the book? It raises the problem: is AI dangerous? Coppelia is a mechanical doll whose inventor brings her to life. The story is told in a well-known and often performed ballet. In the story, the inventor is disappointed by his doll, which comes to life and proceeds to fall in love and marry a young man, thus deserting her inventor.
The Turing test, created by pioneering computer scientist Alan Turing, comes up a lot in sci-fi culture and discussions about intelligent robots. But what exactly is the Turing test, and what does it mean if a computer passes it? Alan Turing first described what we call the Turing test in a 1950 paper. Turing wanted to answer the question, can machines think? To get to the bottom of this, he devised a hypothetical test. Imagine a game with 3 players. One player, the interrogator, is isolated from the other 2 players, one of whom is human and one of whom is a computer. The interrogator's job is to try and figure out which is the human and which is the computer by asking questions of both. To make things harder, the computer is trying to make the interrogator guess wrongly. In other words, it's trying to be as indistinguishable from a human as possible. If, more often than not, the interrogator is unable to determine computer from human, then hey, maybe we're dealing with a thinking computer. Attempts to build computers that can fool humans have revealed some fascinating challenges. For instance, it's hard to make a computer that's good at telling jokes. The Turing test isn't a perfect test of robot intelligence. For example, it encourages trickery. One recent attempt involved a program pretending to be a young boy for whom English wasn't a first language, conveniently covering up any linguistic slips. The Turing test also doesn't account for non-human intelligence. Some of the smartest computers around today have no chance of pretending to be a person, but that doesn't make the advances in AI that they represent any less impressive. So just because a computer looks like it's passed the Turing test doesn't mean we have to bow down to our robot overlords just yet. But nevertheless, Turing's experiment gives us plenty to think about in terms of how we define intelligent behaviour and what we would want from an intelligent robot. And after all, who doesn't like thinking about robots?
John McCarthy coined the term artificial intelligence and created a summer institute at Dartmouth in 1956 to bring together a variety of people who were involved with the development of artificial intelligence. AI has the opportunity to use a variety of knowledge bases and is encyclopedically knowledgeable. We've looked at AI from antiquity and its beginnings in the myth of Pygmalion and Galatea, and the next slide will show a modern engineer and what he has developed with regard to artificial intelligence.
At a museum in Tokyo, researchers have set up a workshop where they're looking to prove that robots can be imbued with life.
Hello, Ashley.
Eat your red pill and try to keep up. Professor Takashi Ikegami has helped create this thing, which looks like it comes straight from Ex Machina Central Casting. Through a series of sensors and artificial intelligence software, this android looks out into the world and reacts to what it sees. The android is in effect evolving based on what its AI software seems to like.
Basically, there are two different mechanisms. One is autonomous rhythm generators. It's coupled with each other. Also, there's artificial neural networks spontaneously firing and sending signals to each other.
As someone approaches the android, the sensors detect the movement. And then the software kicks in to determine how the robot will move in response. But for the moment, it has a movement style that could be described as that really drunk guy at the party.
Okay, so in each one of these sensor boxes, right here, there's two cameras.
Yeah.
And this is measuring the
distance, yes.
So when I come closer or further away from the machine,
then robot has to do something.
It has to react to that.
Yeah.
You guys will add more and more sensors over time.
We can put like a temperature sensors, sound sensors, many other sensors.
Armed with more sensors, the robot can make more judgments about its environment and more nuanced reactions. Over time, the movements and gurgles change. The thinking is that the robot will eventually form its own personality and possibly even language.
What's the deal with the noise? Is it hungry?
This sound is designed by my student. And the behavior is modifying those sounds. The sound is changing all the time. It's more like, a primitive language. That's, I think, the interesting part of it. Like our babies, we don't have to tell everything to the baby, but baby can learn unconsciously by interacting with people, interacting with the environment, right? Once we have a bunch of lifelike systems around us, maybe our concept of what is life will be very much different. And then if we want to coexist with robots, then we maybe have to learn different languages, different way of thinking.
So that doesn't freak you out? You think that's a utopia?
I think it's much more ideal to me compared with this, very violent world right now.
Well, thank you for letting me see your android.
Thank you very much.
Thank you.
Oh, he said something. I think he said he likes you.
AI research takes many forms, from teaching machines to learn from experience to connecting with the Internet of Things. AI is being implemented in transportation, home service and robotics, healthcare, education, low-resource communities, public safety and security, employment and the workplace, and entertainment. Thank you for your kind attention.